Morning, everybody. We're going to continue talking about statistics today. And today we're going to look at group data. We're going to look at ways to measure spread. Last class we looked at ways to measure center. And then we're going to look at box and whisker plots. So a couple of things. So when you're working in these classes, when you're working in these age ranges of like 21 to 25 or 26 to 30, anytime that you've got an interval and you don't know the exact amount of data that is in each one. Like, for example, we know there are 11 people who are in the 21 to 25 age group, but do we know how many 21-year-olds we have, 22-year-olds, 23-year-olds, 24-year-olds, 25-year-olds we have? The assumption is that we don't. And so what you can do to approximate this is if you look at an interval and you say, okay, for example, if your interval is 21 to 25, you can use a midpoint to estimate this. So to find the mean, we're going to be multiplying, but we're going to be multiplying by the midpoint of the interval. So if the interval is 21 to 25, in your head you should be thinking, okay, the middle age there is in fact 23. So whenever I'm going to be counting how many people I have in this age group, the only thing that we can do is do an approximation. So we're going to say everyone in here on average is 23 years old. So in total, we're going to have, if we multiply those things together, 11 times 23, that's going to give us 253. So for each of these, when we're trying to figure out the average age of people who completed who we got this information from, these bus drivers here, we're going to go to the midpoint. So for 26 to 30, we'd say, okay, for 26 to 30, what is the midpoint there? That is 28. 14 times 28 is going to give me 392. So then we're going to keep this process rolling. The midpoint of 31 and 33. So let's see, we're going to say midpoint here is 33. 32 times 33 is going to give me 1,056. Let's see, 27 of 36, that's going to be 38. 27 times 38 is going to give me 1,026. The midpoint here is going to be a 41 to 45 is 43 years old. We'll say 43 times 29. That's going to give me 1,247. Midpoint of 46 to 50, that is 48 years old. 17 times 48 is going to be 816. And then 53 is the midpoint for 51 to 55. 53 times 7 is going to give me 371. So whenever we're calculating the mean here now, we're going to add up all of these ages right here, because this is the total amount of years that have been lived. This is our approximation. So we're going to add up all of these things, and then we're going to divide it by however many people answered here. So let's see. If you add up all of these things here, you're going to get, so we're going to say that the mean here, X bar, is equal to 5,161. And then if you add up the frequency of everybody that responded here, we'll say 5,161 years divided by 137 people. And if you calculate that, we're going to get the average age here. Our X bar here, our mean, is going to be 37.7 years old. So kind of to summarize what we did there, in order to find, if you have intervals and you don't have specific data points, to approximate the mean, I should put approximation signs there, shouldn't I? To approximate the mean, you need to calculate the midpoint of the interval. And then when you're calculating the mean, that's what you're going to be multiplying by. So then that's it for that section. The next thing that we're going to look at here is going to be measuring the spread of data. So there's a couple of different ways to measure spread here. So the ones that we're going to talk about today are going to be the range, which you all have probably heard of, and then the interquartile range, which you all have may have heard of, and then the two that you've probably heard of, standard deviation. We're going to talk about that after fall break. Variance may be the one you haven't heard of, but variance and standard deviation are very well connected, very well put together. And so we'll talk about those in a bit. Now, to calculate the range, all that you're going to do is you're going to look at the highest data point, you're going to look at the lowest data point, and you're going to subtract those. And it's going to tell you how long is that data set. Now, the thing is, with it using two data values here, the downside is that it's not particularly reliable. Really, the only thing that range gets used for is creating those intervals, like what we saw on the last example, where if you're like, well, my range is 50, let's cut this up into groups of 5 or into groups of 10. But it's not particularly good for telling you much else about the spread. So when you're looking at an example of calculating range, all that you've got to do is say, okay, for example, if I'm looking at the weight of pumpkins, I'm going to look and try to find the range of this data. So I'm going to scan to see what the lowest data point is and what the highest data point is for this. So looking here, the lowest one looks like it is 2.1 there. And then the highest one looks like it's 5.1 there. So for the range of this problem, all that we would have to do is say, okay, well, that range is going to be 5.1 minus 2.1. And so the range here, the width of this data set is going to be 3 kilograms. And so chances are that you've probably seen that before. Like that shouldn't be super ground changing, super earth shattering or anything for you. So the next thing though, this is probably going to be some newer information for you, is we're going to talk about the interquartile range. So we're going to be talking about quartiles of data today. Now, something that we have talked about already is that the median is what cuts it into 2 halves. But when you take those halves and you cut them into other halves, we get what are called quartiles, which should sound very familiar to you all. It's derived from that word quarter, which stands for a fourth or 25%. So a couple of vocabulary things. The middle value of the lower half, the smallest quarter that we have, is called the lower quartile, can also be known as the first quartile or Q1. And that's the first 25% of data values. They fall below that point. The middle value of the upper half is called the upper quartile or the Q3. And you think about how much money is 3/4. That is the 75% mark of a data set. Now, interquartile range is calculated very similarly as regular ranges, except you are just subtracting the upper quartile minus the lower quartile there. So whenever you're calculating the interquartile range for something, you have to first find the median. So when we're looking at this data set down here, right here, 5, 5, 7, it goes on. The first thing before you can find anything with quartiles is that you've got to find the median, which means that we're going to have to order this list in order to find the median. So I'm going to go ahead and put this list in order really quickly. So 2, let's see, 3, 3, 4, 4, 5, 5, 5. I see 2 6s, 2 7s, and an 8. And I'm going to go ahead and put commas in between all that. So let's see, how many terms do we have here? 3, 6, 9, 12. 13. So that means that the seventh data value, so 1, 2, 3, 4, 5, 6, 7. So this guy right here is our median. Now, whenever we create this median right here, whenever we pick that, that cuts our data in half. So if you put this pin right there and you're like, okay, well, we've effectively created two halves there. So now we need to look at each half and figure out basically the median of those halves. So since this has 1, 2, 3, 4, 5, 6 values right there, the median is going to be between these two values, between 6 and between 7. So that's going to be 6.5, and this is what we're going to call our upper quartile. You can call it the third quartile. Q3, it goes by many names. And on the other side here, 1, 2, 3, 4, 5, 6, even amount of data points. The number in between these is 3.5. That's your lower quartile or your first quartile. This is the value that 25% of the data set should fall below. So we found the median here. We found quartile 1 and quartile 3. Those are here and here. And then to find the IQR, all that you're going to do is Q3, the third quartile minus the first quartile. So in this case, the IQR is going to be 6.5 minus 3.5, which is going to be 3. So far, so good, hopefully. If you all have questions on this, feel free to ask. But part of the reason that we calculate those quartiles is to numerically decide outliers. So we're going to look at that next class, but also you can use what we just calculated to use a different way to illustrate data. So the way that you can illustrate data from that is you can create what's called a box and whisker diagram. And so you may also hear it called a box plot. So a box plot is just a graph using the 5-number summary of a data set. And so what that 5-number summary is here, the 5 things that comprise it, is that you have the minimum value, which is the smallest value. You have the first quartile. You have the median, which you may also now from here on see referred to as quartile 2, which is the 50% mark. The upper quartile, which is Q3, and the maximum value. So if you're following along in that in your textbook at all, I'm using data from example 7 just to create an example box plot. So the way that a box plot works is that you're going to put a dot where the minimum value is and a dot where the maximum value is. And you're going to draw what's called these whiskers to wherever the first and the third quartile are. So Q1 is here at 16, Q3 is here at 24, and you're going to create a box with those. Now this box represents 50% of the middle data points, because from Q1, which is 25, to Q3, which is 75, and then you have the median here, which is just a slice, or it's just a dash through your box. So whenever you're creating a box plot, this is a general look for how it's going to go. The min, the max are always points on the end. The whiskers connect to the quartiles, and then the median is a slice down the middle. So a couple things there. I talked about that box representing the middle half, the middle 50% of the data. The lower whisker over here represents 25% of the data with the smallest values. And the upper whisker here from past Q3 is the upper 25% of values. So if you need to look at the different types of graph shapes, we went over those last section, but if you need to look at those, I would go look at page 324 in that book. I did not feel like drawing all of those different shapes, I'll be honest, when my pictures won't be quite as good. So you can go look at those on there. But I do want to do an example where we draw a box plot real quick. So let's see here. So we're going to be doing example 8. I didn't write a page number for it. It's page 324. So on page 324, so the first thing that we've got to do is to draw a box plot, we have to have a 5-number summary for this data. So let's see here. The first thing that we've got to do is calculate the median. If there's 16, that's going to occur between 8 and 9. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Between 8 and 9 is going to be the value, or between 5 and 5 is the value of 5. This is going to be our median right here. That's what's going to split this data down the middle. So after we do that, we've cut it into halves now. It should be 8 and 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have to find the upper and the lower quartiles here. So let's see, 1, 2, 3, 4, 5. Between 6 and 6 is 6. That's going to be our third quartile. And then let's see, 1, 2, 3, 4. Between 2 and 3 is going to be 2.5. So this is Q3, this is Q1, and then the min and the max are just on the ends here. So we've got the max over here, we've got the min right here, and that is our 5-number summary. Is just saying that min equals 2, Q1 is 2.5, the median or the Q2, whatever you want to call it, is 5, that the Q3 is 6, and that the maximum value here is 9. That's our 5-number summary. So once we've got this information here, I'm going to draw just a regular old axis here. Let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's see, 2 is going to be our minimum here. So I'm going to put a point there. The Q1 occurs at 2.5. So we're going to have a really short whisker there. And it goes all the way to 6. We've got that box right there. The median occurs at 5. So there's going to be a slice through that. And then we have the maximum at 9. And we'll have a whisker going through there. So the actual range here. So we want to find the range and the IQR. So graphically what you're finding when you find the range. So we'll do the range in pink here. Is you're calculating this distance right here. The distance between the longest point and the shortest point. So that's going to be 9 minus 2, which is going to be 7. And then for the IQR, you're doing this distance right here. You're finding how long this box is on a box and whisker plot. So the Q3 here, so that's Q3 minus Q1, so that's going to be 6 minus 2.5, which is 3.5. And then the last thing here for D was to find the percentage of data values, which are less than 3. So if we looked at that ordered list, there were, I believe, 4 data values less than 2. So, or less than 3, excuse me, which also makes sense with our quartile 1 here. The quartile 1 is the point. It was 2.5 that 25% of your data lies below. Ideally, it worked out well that 16 is perfectly divisible into a quarter. So let's see, there are 4 values less than 2 out of 16 total. which would just be a quarter, which is 25%, which is also, we could have used Q1 to find that. So that is all I have for today. I will have a short homework assignment to go with this, but my expectation is that this homework assignment is done tomorrow. Don't go and say, Mr. Price, what's up with him? He gave us homework over fall break. It's going to be a short assignment. My expectation is that it gets done on Wednesday. I don't want you all thinking, Mr. Price is assigning homework over fall break. Take advantage of that Wednesday, of that Connect Day, and make sure that you all get this assignment done. So if you all have any questions at all, feel free to stop by in the Zoom or shoot me an email. Thanks.